Alright, a lot of people are working on their projects. Some folk haven't uploaded anything to the interim project folders yet. I threw in a couple of project ideas. Just in case you haven't already picked one and you need to start working on it, please don't wait till the last week, guys. So, 2 more project ideas. These don't involve really, like dictionaries and file I/O and stuff like that. So, they're not too hard. Although I need to somehow make the password checker a little bit hard, or I should ask you to find a way to improve upon what I have there. Anyways, maybe make it a GUI, I don't know. Risk Dice Simulator. Surely maybe you've played the game of Risk. Where you pile up a bunch of armies on countries and you attack other countries based on the number of dice you can roll. If you have 3 armies, you can roll 3 dice. If you have only 2 armies, you can roll 2 dice. If you only have 1 army, you can only roll 1 die. Same for the defending side. If they have 2 armies or more, they can roll 2 dice, maximum of 2. Defender rolls a maximum of 3. Please feel free to Google the rules of Risk if you haven't played it before. So the attacker can roll 1, 2, or 3 dice. The defender can roll 1 or 2. The defender can lose up to 2 armies for the attack if they've risked 2 by rolling 2. Or the attacker can lose up to 2 armies. The dice are rolled, the highest values are compared, and the higher values win, but the matched rolls go to the defender. So say that they're both rolling the same number of dice. The attacker rolls 2 dice, they roll a 6 and a 4. The defender rolls 2 dice, a 5 and a 4. Well, the 6 beats the 5, but matches go to the defender. So the attacker loses 1, the defender loses 1. How about 3 dice? Attacker rolls a 4, 3, and a 2. The defender rolls a 2 and a 2. A 4 beats a 2. The 3 beats a 2. So write a program that gives the attacker 20 units, the defender 20 units, and then fights a battle according to one of 4 possibilities. And if you feel like kind of revising it different than this, I still want to be able to figure out, though. I've always been curious, like, what is the best strategy for defending? Just roll 2 dice each time and take the risk of losing 2? Just roll 1 die? Anyways, that's the idea here. We've got to figure out what the best strategy is. The attacker could max out their dice, and so could the defender. The attacker could be conservative and roll only 2 dice. That wouldn't make sense, actually, but it's kind of just a check to see. The attacker should lose in that circumstance, right? Because if they're both rolling 2 dice, but ties go to the defender, then the defender will usually win. The attacker rolls 2 dice and the defender rolls 1. The attacker rolls 1 die and the defender rolls 1. That's another time when the defender should win. So I'm just curious, really curious about 1 and 3. So the attacks continue until one side or the other runs out of armies. Display the results saying who won and how many the winning side has remaining. That might be fun. Random numbers, dice. The rules are a lot easier to understand than the Pie Fighter game. And another one, a password checker. And somehow this needs to be made a little bit more difficult. So that'll be part of your project, is to figure out how to make this one worthy of being a project. The deal is that a password has to meet certain rules. It has to have 1 uppercase letter, 1 lowercase letter, must have 1 digit, must have 1 punctuation symbol, no spaces, and be 8 characters in length. I should have said at least 8. But if you follow this exactly, then that'd be okay too. So the program will loop until the user picks a valid password. And I said, or better, the program will read a file of passwords, printing each one, and saying whether it is valid. Kind of like to do that, or if you can think of something else to do with it, feel free. So, if you've already picked a project and are going towards it, great. If you've picked a project but haven't made a start and you want to switch towards one of the new ones, great. Whichever. If you're not going to do a project, well, don't go that way. Please, everybody, do a project. All right, I want to talk about classes today. We're just about pretty much done with all the material from the book I wanted to cover, except with the exception of classes, because once we've talked about lists and functions and dictionaries, all of which we've talked about up to this point, then we've covered what I consider the prime material that I want you to know out of a scripting class, enough that you could go and Google up additional information if you needed to learn something else, right? That's why we took an extra class period to talk about, doing the port scanner. Conceivably, that could have been one of the slots that we used, I used up an entire lecture period on it because I thought it was useful seeing how you could create something that we really had no idea how to do until we started Googling it. So the idea of functions. We know what a function is, but we're going to cover it again anyways. We're just going to write a couple of utility functions, just for our sake. Kind of the last thing of the chapter that we want to cover. So what is a function? It's a named body of code that can accept parameters and can return a value. Or named block of code that can accept parameters and can return a value. They don't have to accept parameters. They don't have to return a value, but they can. So, like the silly example of a function. DEF add. We're going to add two numbers together. We're going to add x and y. So add x and y. The return value is equal to x plus y, and then return r, right? They don't get much simpler than that one, unless it's just something that prints a message and doesn't return anything. Let's write something a little bit more interesting. Let's write something that converts an array to a string. Convert array to string. And what does it do? Converts array AR to a string and returns it. Now this is kind of document string or doc string. Why do I have that there? Let me show you. I'm just going to make it return with nothing else so that I can actually, get it going as fast as possible. HIJK, are we really on L? I think we are. Are we on M? L? L is in we love Python. Alrighty. Okay, so when I run it, I got a problem. It's not return. Fix that. Alrighty. And so now that that function is in memory because I run it, I can do help add, and it doesn't tell me anything about it, right? It tells me the parameter list, that's it. But if I do help convert array to string, then it tells me more information, or not because I typed the whole word convert rather than just conv. Help conv, you know your function name is too long if you get annoyed typing it over and over, right? And it gives me some information. What does it do? Convert array to string. Converts array AR to a string and returns it. So that's why you could use those triple quote comments, a document string, so that you could do help on it. And plus, it's not a bad idea just to have a little description of what the function does. All right, so we have a string. We have an array, and we want to convert it to a string. Now, really, you could do this in one of 3, 4, 5 different ways. You could write a loop. You could create an empty string. You could add every element to the array to the string. We're just going to cheat. We're going to use join. We're going to join based on an empty string so that every element in it gets all concatenated appendage against each other. I guess we could make a separator, right? Separator field, so that we might want to put commas between them, something like that. But anyways, our return value is equal to the separator dot join, and we're joining that array to a string. And then we're going to return R. Let's test it out. Let's make a silly array. AR equals square, quote, H, end quote, comma, quote, E, end quote, comma, L, end quote, comma, L, end quote, comma, quote, O. Now let's convert that to an array. S equals CON, oh, that name is way too long. How about ARR2 string? I like that better. ARR2 string, and we're going to pass in that array, and we want a separator of no separators. We just want to concatenate everything together so that when we get that string back, we can print out hello with no spaces. Print AR. Whoops, I printed out the array. That's well and good, right? But I'm actually curious about the string. Print S. And it's all joined together, right? Why would you want to do that? Well, I don't know. If you're writing a hangman game or you're doing some cryptography, right, and you need to manipulate your data, you might turn the string into an array so that you can change all the pieces of data in it. Why? Because strings are immutable. What does that mean? What if I have a string like this? Name is equal to Jeff, right? And then I want to change that J to something else. In subscript 0 is equal to, I don't know, I want it to be a lowercase j. That's a syntax error. Strings are immutable, so this is an error. What does immutable mean? It means that you can't change the values in the middle of it. All right, boom. The string object does not support item assignment. And that's uncool because if it was an array, we could. Right? If I did AR subscript 0 is equal to, you know, a J, that's fine. That's not a syntax error. So you can change the elements of an array. Easy. Easy peasy. But you can't for a string. So maybe we ought to write a function that'll do that. That'll replace a single element in a string. Because oddly enough, Python doesn't support that. So why don't we write another function called replace char. Replace char. C-H-A-R. I better stop. Do we have syntax errors that we would like? I am rocketing through this, and I know that I do not give enough time for typing. I don't hear any keystrokes. I guess we've all caught up. All right. So def replace underscore char. It's going to take a string, and it's going to take a character, or an index value, and it's going to take a character to replace at that specific value, right? So if I want to replace the first letter of my string, I will pass in an index value of 0, and I will put a CH there. I'll pass in something. Let's document what it does. Replaces the character at the specified index with the CH character and returns the string. Now there is a function that does a global replace, right? You want to replace all the lowercase a's with uppercase a's, you call string.replace and it'll do it. But this, say we just want to change one of them. Sometimes you don't want to change them all. All right. I'm going to change my comment a little bit more. Replaces the character at the specific index of string S with the character CH and returns the string. This can be actually done in a single command with slicing. Why slicing? What we want to do is we want to get, like if we're trying to change that L, we want to get a slice that has these 3 characters. We want to put a new character in, and then we want the last of them all the way to the end, right? So it's going to be 2 slices with something joined between them. We're just making some utility functions. And if some of these seem useful for projects, great. All right, so our return string is going to equal the string starting at character 0 and then going up to the index. So like if they say 2, it's going to get 0 and 1. So that's our first slice. Plus, we're going to concatenate CH onto it. And now we're going to get the rest of it. So the slice starting at index value +1 and going to the end. Remember, if you leave off the thing after the colon, it goes all the way to the end. Remember, if you leave off the number before the colon, it starts at the beginning. So we could do it like that. And then we could return R. that makes sense. We're getting everything up to the index value. So if they want to change character 3, we're getting 0, 1, and 2. And then we add our character to the string, and then we get everything after that. Well, we better test it, right? So, print, parentheses, let's do it the whole way. S is equal to, rows state. And I want to replace the A with something, or the O. The S, because that's position 2. It's easy to figure out for me. So S equals replace underscore car, passing that string in. It's at position 2 because I want to replace the S. And I want to put a capital S there instead for some reason, or a question mark, I don't know. And then I'm going to print out S. It's not going to say row state anymore, it's going to say RO question mark. All right, cool, that worked. All right, I'll be right there. So these are called parameter or parameter variables. They get filled in with the arguments that are passed to them. Time to pause. All right. So we have a function that takes an array to a string. How about another one that takes a string to an array? Well, we have dot split, but dot split requires like commas or spaces or things like that. And so maybe we will use list comprehension. We could create an empty array and then step through the string character by character and return that, or we could use list comprehension. I'm thinking let's do it that other way because it's more traditional. String underscore to underscore array, and for now I'm going to skip making a triple line comment since that was a problem to you. Maybe I'll go back and add it after it's all done. And we're going to pass in a string. No, we're going to pass in a string. So our array is going to start off as an empty array, 2 squares, square braces. And now we're going to use a for loop, and we're going to step through every character of the string. So for space ch space n, can I type? N space s colon, append that to the array. I'm calling them arrays, and I'm sorry, it's because I've taught 2 fundamental sections today, and we all know that in this language they're called lists. Sorry about that. So I should do a search and replace, and everywhere the word array appears, change it to the word list. Phooey. Alrighty. That's a step in the right direction. Okay, so ar.append ch. And then back tab 1 and return that. So while I'm at it, I'm going to change this to called list to string. List. And once I make sure that all this works, I need to go find out where I had AR to string down here and rename that list to string. Okay. There. Now that I've broken my code and hopefully fixed it by changing those names. Alright, we didn't call that function, but at least it ran without a syntax error. So I'm going to go ahead and add a doc string here. Full quote. Convert string s to an array with each element being 1 character. Close quotes. Yes.
Sorry.
Yes. Thank you. Yay, thank you. I have arrays on the brain. Okay.
Yes, arrays or lists.
All right. I need to test out that function as well. So as soon as I think that most of us have typed that, I'm going to scroll down here and we're going to create an array. A list. We're going to create a list. All right. 8. Nope, we're gonna, yeah. Is that what we're doing?
I think it was string to list, right?
String to list, list to string, string to list. You're correct. We're gonna replace, well, we already have a string right here. Why don't we just use that one? So, AR is equal to list to underscore string and pass in that string, and then let's print it out.
You did list to string and it should be string to list. Because you, for your argument, you put in a string.
Right, you're right. String underscore to underscore list. And if I'd made a change I'd planned on doing, then that would have completely mystified me in a minute. I want to make sure this works. Okay, so that worked. Did it? I didn't print out the array. All right, so S comma AR. I want to see both of them. So I futzed with this a couple of times, run it, and there we go. Right, it turned that string into an array, which we could then turn back into a string with the other function. Please somebody erase my brain. I guess I'm just going to give up, and if I call it array, just accept that I'm stuck on arrays today. Okay, one more thing I want to talk about while we are talking about functions, before we start talking about classes.
Do you need help?
Anybody need typo help or more time?
I'm just getting that stupid error message.
Okay, let me do this and then I'll come back here. Okay, so the problem, and I know I've mentioned this, so I'm not going to explain it too long. The problem with sticking your code at the base indent level with an indentation level of 0 is that if we imported this file into another file, it would run all this code. And we've written some cool functions. We might want to be able to use these inside another Python file, but if we did, it would run all this indented code. So we're going to stick all of this inside a main function, and then we're going to call it. So def main, parentheses in parentheses, colon. And then take everything after that and just tab it. But then we have to call main. And sure, we could go down to the very bottom and just put main parentheses in parentheses at the 0th indentation level, but then it has the same problem. As soon as we imported it, it would trigger it. So instead, we're going to add a if statement. If underscore underscore 2 underscores for a total of 4 on this variable name. If underscore underscore name underscore underscore equals equals. Kind of sounds like Dr. Seuss. Underscore underscore equal equal. Quote underscore underscore main underscore underscore end quote colon. Then call the main function. So now that we have that there, the code will run if we actually run this Python file, but if we import it, it will not run. And we could test that by going to another file and importing it, and we would prove that it didn't work. And the reason why is that when we run this Python file, then that hidden variable, that surprise variable, does in fact equal main. But if we import this file from another one, then that variable is set equal to lecturel.py or whatever file we're currently in.
So like this is a container that we can call to other Python programs.
Right, we could import this and then we could call main, or we could call any of these other functions. And so that's why you do that, is that you're creating a library of functions.
Oh, so like when we import math.
Right, exactly, because you wouldn't want math to go off lickety-split and print 1,000 things just because we imported it.
Okay.
We would not want this to do all of that stuff just because we imported it. Had the recording pause for a moment. I've made a few changes. Check out these 3 lines. Pause the recording, make the changes. And what you'll see here is that on the call to list a string here, we did not provide a separator parameter. The reason we were able to get away with that is because on the list to string function, we gave it a default value for the parameter. If 1 is given, then we use that one. If none is given, then we go ahead and use the empty string so that when we join them together, there's no spaces. About time to talk about classes.
Just go down to the bottom real quick.
Yep. How far down?
All the way to the main function.
There we go.
Make sure that it's typed in correctly. Okay. Yes.
What is a class? A class is a blueprint, a template for a collection of data. Right now, we've just been, yes. Okay. All right, just a sec. All right, so what is a class? A class is a template for a collection of data and the functions that can act upon it. Now, we've been using classes even though we haven't known about it. Strings are classes, turtles are classes. We've been using classes all left and right. The string, for example, what is its data? It's a series of characters. What are the functions? Things like dot replace and dot is upper, things like that. So, we wanted to declare a class. I'm thinking about sticking it right here between the main and the if name, just because that's easier to see. Want to make sure I absolutely get. All right. So, what kind of thing are we going to do? Maybe we're going to do a sphere class so that we can calculate the volume and the radius of a sphere. So class, sphere. Now just by tradition, people usually make the class name an uppercase letter. Colon. And so we need to add what's called an init function to initialize the data in the class. So if this sphere is going to have a radius or something like that, then our init function needs to set the radius. So underscore underscore init underscore underscore parentheses in parentheses colon. Excuse me, between the parentheses we need to put self. If you've taken Java, if you've taken C++, C#, you're used to the idea of a this reference. In this language they call it self, but we could actually put the word this there and it would work just as well. Okay, so self.radius is equal to 0. As soon as they create a sphere, it's going to have some data associated with it, but we're just setting it equal to 0. Now we might want some functions. We might want a method that'll return the volume of that function. What is a method? It's a function that's attached to data. It's part of a class. So def get underscore area, or get underscore volume. And every function we add to this class has to have this self-reference, just so that we can keep track of the data that's involved in it. Well, let's calculate the area. Area, what? No, it's volume. V is equal to pi r 4/3 pi r cubed. So 4 divided by 3 times pi 3.14159 times the radius self dot radius to the power of 3 cubed, and then return V. Let's get the circumference of the sphere as well, just because I happen to remember that formula. It's 2 pi r. Def get underscore circum parentheses self in parentheses colon. Let's get the circumference. C is equal to 2 pi r, so 2 times 3.14159. If you feel like importing math and using the precise value of pi, or at least much more precise. There is no precise value of pi, right? It's an infinitely long number. Times this dot radius. return
So,
C.
right
Did
here.
I make a mistake?
You put this in.
I put this just like, okay.
Yeah, you said that would work.
Yeah,
right?
well, if we change that to this
Okay.
keyword, it would work. And I should be consistent all the way through. If I like the word this, I should use it everywhere, but I could give you a demonstration that it works either way, but the word just has to be the same. Let's use our sphere. Down here after the call to main, maybe I'll make a sphere. S1 equals sphere, capital S, just because I called it capital S up here. And then let's set the radius of the sphere. S1 dot radius, there I go, radius with the IUS is equal to 10. Let's print the volume and print the circumference of it. Print parentheses, quote, sphere radius equals, end quote, comma, S1 dot radius. Now radius is a variable, so we did not put parentheses after it when we invoked it. We could make a function called radius or get radius or something that would return it, but we didn't, so I'm just going to leave it like that because it's a variable known as a member variable, which is defined here, and we can define as many member variables as we want inside the init function. All right, now I'm just going to copy this. I should not copy it. Print, parentheses, quote, volume equals, end quote, comma, S1 dot get underscore volume, parentheses, end parentheses, parentheses, yeah, close parentheses. And then the same thing for circumference. Print circumference equals S1 dot get circum. Print parentheses, quote, circumference equals, end quote, comma, S1 dot get underscore circum, parentheses, end parentheses, end parentheses. I'm going to move the call to main, or I'm going to comment it out or something. I'm going to push it, yeah, down here and comment it out because I want as much code on the screen as we can have right now. All right, I want the entire class and the example code underneath it. Still didn't work. Guess if I take that blank line out there, it will work. All right. So, this sphere has a piece of data associated with it, dot radius, and it has two functions called methods that will act upon that data. A class can have as much data as it wants. The turtle class has a whole bunch of pieces of data involved. It's got, the x, y coordinates of it, the angle that it's traveling at, what color its pin is, what color its speed is, whether the pin is up, the pin is down, stuff like that. It's got a lot of data. And it's also got a lot of methods for drawing, going left, going right, going forward, going back, setting your new XY position and stuff. Let's make sure this works before I brag too much about it.
Yeah, I was wondering.
Why did that not work? Check out the other methods. What did I do wrong here? I just left off the word DEF. Now we have more of a hope of running. All right. And so the volume of that sphere, I assume that calculation is correct. Pi r squared 4 over 3 times, well, I'm not convinced it's correct, but I'm going to run with it anyway. I think I'm going to set the radius to 1. My brain can handle those numbers. 4 times 3 times pi is about 4. Yeah, I think that's right. Okay. So I want you to add another method using the formula for the area of a sphere, which unfortunately I'd have to Google. Okay, it's just 4 pi r squared. Go ahead and add a method to your class. And then write a print statement that calls it. Just call it get area. Maybe I won't solve it in front of everybody, right? Okay, so that is one example of a class. This is kind of annoying, this part right here, where we have to set the radius right afterwards. Wouldn't it be neat if we could do this? I want a sphere with a radius of 1. We could do that, but we'd have to make an argument. We'd have to make a parameter that we could pass that to. Let's give another example for a class rather than do that one. How about a triangle class? DEF triangle, capital T, colon.
We don't have to put class in front of it.
Yes, we do. Thank you. Remove that word DEF. Thank you very much. Replace that with the word class. Class space triangle colon. Now we need to define the init method, so we're going to have to use those double underscore pairs again. DEF underscore underscore init underscore underscore parentheses self, but we need some parameters for the base and the height of the triangle as well. Base, comma, height in parentheses colon. And now we need to set this dot base equal to base and this dot height equal to height. This dot base equals base. This dot height equals height. And I forgot to put it as self. Yeah, self dot base is equal to base. So your brain starts going through small loops when you teach Java and immediately followed by Python, or vice versa. Same terminology, same idea. But the book says self, so I don't want to use this. All right. Now the area of a triangle is 1/2 times base times height. So we could write a function that gets the area. DEF. If you want to calculate the perimeter and stuff like that, I think you have to calculate the angles involved or something like that. I'm not going to bother because I don't know how. But get underscore area, parentheses in parentheses colon. Let's calculate the area. It's just 1/2 times base times height. So A equals 0.5 times self dot base times self dot height, and then return A.
Do you need to put the self in the parentheses?
Yes, I do. Yes, I do. This is why some companies pay to have 2 programmers sitting at one workstation, believe it or not. That would drive me crazy to have someone looking over my shoulder, but on the other hand, I'm appreciative of all 12 of y'all doing that. Okay. And suppose we wanted to be able to convert our triangle to a fancy string for printing it out. What do I mean by that? Let's go down to main and create a triangle and then try to print it out. So I'm just going to push all that sphere stuff down. T1 is equal to capital T triangle, and this one's got a base of 10 and a height of 5. And let's print T1 out. Alright, that wasn't very useful. It just displays some kind of memory address in hexadecimal and tells me the name of what the object is. That's not real useful to me. I'd rather print something more useful than that. So I'm going to add a string function to it. In Java, it would be called toString. So it's underscore underscore str. That's going to be the name of our function. def underscore underscore str underscore underscore parentheses self in parentheses colon. And what this has to do is create a string representation of the triangle and return that. And there's always more than one way of making a string. S or R for return value, I'm going to go with S, equals quote triangle base equals percent F, height equals percent F, end quote. The syntax for doing this is always slightly strange looking. Followed by percent sign, and then we need a tuple that passes in this dot base comma this dot height, so parentheses. I better put a backslash here. You can put this all on one line. You can skip doing that backslash and going to the next line. Parentheses, self dot base comma self dot height in parentheses, and then hit return and return S. Now when we run it and print it out, it's going to print something kind of cute. It's going to say triangle base of whatever, height of whatever. And it did, right? We tried to print it out. It called the string function, the str function. What if you need to compare two triangles? Decide which one is larger. Well, what's your criteria for comparing two triangles? Which one's taller? Which one has a larger area? That's probably how I would go about it. Well, there's another function you can create. I think it's called dot equals, or underscore underscore equals. I want to make sure it's not just underscore underscore EQ. Let's add that to the circle class, though. Yeah, let's not. Let's add it to this one right here. So def space underscore underscore EQ underscore underscore parentheses self comma other. We're going to be comparing the self object to the other object. So we're going to see if self.getArea is greater than other getArea, then we're going to return true, else we're going to return false. So self comma other comma if self.get underscore area parentheses in parentheses. Wait, we're just checking to see if they're equal, not if one is larger than the other one. So if self.getArea parentheses in parentheses equals other.get underscore area parentheses in parentheses colon return true, back tab else colon return false. Now you probably recognize you could have just written return self.getArea equals other.getArea. These bottom three lines are kind of useless. I could have just replaced the word if with return and it would have been just as good. So we could create two triangles and compare them to see if they're the same or not. So in a minute, I'm going to go down and I'm going to create another triangle that I expect to have the same area. If this one was 10, 5, that's a surface area, that's an area of 25. What could we do? We could do, 5, 10, or 2 and something. We'll figure it out. So T2 is equal to triangle so if I divide him by 2, Okay, the easiest one, right there. We know that that's going to be the same area. And let's print out T2. And let's print out whether they equal or not. Print T1 equals T2. Should print out either true or false. And by the way, what mistake did I make up here? I did not capitalize true and false. Thank you. Another language difference. All right. So that triangle has that, and they are in fact equal. When we were printing the triangle out, we could have even printed the area out, right? That could have been a third parameter that we printed out, a third, function of that. About time to stop this so that I can check to see how y'all are doing. So I don't want to load y'all up with homework towards the end because I want y'all to be doing projects. But there was a homework assignment that slipped away because it was mentioned in Lecture J, but there was no Dropbox for it and there was no assignment for it. And I'm looking at the wrong class. I need to copy the projects over from that class into the other one. So suddenly, and some of y'all did this, some don't, file and directory access. You'll have to go back in time to remember. You'll have to go back to Lecture J.
What if we put that within the other file? Does it work?
If you've already done it, then just upload it again. Right. Yeah. Okay. And the name of it's wrong. It's not creating files. But anyways, you're going to write a program that loops asking for a directory and a file name, checking to see if the file exists, and printing the file size. It repeats until the user types in quit. So for example, what is the directory name? Dot. And you remember that dot just means the current directory. What is the file name? Review.txt. That's what they typed in. It sure would be nice if you got a directory listing and printed it so that they would know possible file names. And change that directory, and the file review.txt does exist in this directory, and that's its size. But then you give it a directory name of a dot, and you type in file name of I-don't-know.txt. It changes that directory, still the current working directory, but that file does not exist in the directory, so it can't get the file size. And then what is the directory name? Quit. All right, done. All right, a whole bunch of hints. Here's how you change directories. I added the hints since, it's been a while since we talked about this, and you may not have done it that week. You can get the current working directory if you want to display it with os.cwd. It sure would be neat if you displayed it after this message, right? Now changing directory to dot. To find out if it's a file, you use os.stat.isFile. Remember, you have to add import os at the top of your program in order to get it to work. I should even add that as a comment. Thanks for this horrible looking.
Did you write that?
The D2L helps create your HTML, but then it mangles it after you enter it all. So when I made the HTML, it looked a lot cleaner than that. All right, so hints. Add import OS to the top of your code. You can change directory paths with oh.chdr. You get the current working directory if you want it, like that. That's how you find out if it's a file. This is how you find out if it's a path, if it's a directory. I didn't ask you to find out if it's a directory, but you could, right? You could check to see that the path they typed in did exist before you tried to change it to it, because if you don't, then it'll generate an exception. I didn't make it a must to check for that, but you could. os.stat.getSize returns the size of the file. Remember that a dot means current directory. Rather than printing in this directory, it'd be neat if you actually printed out the files. You can get the current working directory like that. You can check to see if directory exists with isdir. You might want to do that before you call changedir. Suggestion: consider letting the user type in question mark and giving them a directory. right? If you wanted to, it could be just as easy as print os.listdir, like that, right? But, or you can make it prettier, something like that. And to test it out, try a period as your current directory, use a slash as your directory, use a valid file name, use an invalid file name, just to make sure it doesn't crash under those circumstances. All right. As far as homework over classes go, I want to make this one pretty simple so that, like I said, you can keep working on your program, on your project. So it's going to be a short one. Write a class that represents a block. Blocks have a height and a width and a depth. Add a get volume method function that calculates the volume and returns it. Hint, the formula for the volume would be self-height times self-width times self-depth. I'd like for you to add a __ str method. Make absolutely sure there's an init method. I don't care which of the two ways you do it. We saw two ways, right? We saw a radius where we set radius outside of the constructor of the init function, right, by that. And we wrote another one where you did get to use the init function to pass in pieces of data. Either way is fine. Whichever example you want to follow is fine. Right? That makes sense? That one ought to be short. Hopefully, because you ought to be able to reuse the material that we used during the lecture.